Hi guys, I'm Teacher Boaz, just as usual. Today we are going to do some questions in matrices, which is also in mathematics. So basically, when we talk about matrices, we simply mean an array of numbers. An example somebody can give you, you have A, B, C, and D. But remember one thing, when we talk about a matrix, or that array of numbers, there's some of the key areas we will consider today. For example, if you look at the vertical column, so this is called column 1, and we have the column 2. Then horizontally, this is row 1, this is row 1, then we go to row 2. You need first of all to understand the basics. So these are columns, and the horizontal one are rows. Now when you have a matrix of this nature, you can be asked the plus to minus to multiply, and also to get other factors like determinants. I would start with a very simple basic. If I give you 4, 7, 3, and 2, if this is a matrix, then you multiply with another matrix. An example 1, -2, 0, and 4. Now when you get the product of these two matrices, there is a rule that normally says, we call it RC. RC in matrices means you take the rows, you multiply by the columns. Now, how do I get the solution here when I multiply these two matrices? If I want to get at this corner, we know very well that this is supposed to be column 1, column 2. Then I'll get row 1 and row 2. So at this step, I want to get the column 1 and row 1. So what will I do? We will take the first row times first column. The first row is 4, 7. The first column is 1, 0. So you take the element here, which is 4 times 1 plus 7 times 0. So this is 4 plus 0 we get here to be 4. If you want the element here, which is column 1 and row 2, so I'll take the first column and I multiply by row 2. So we start 4 times 1 plus 7 times 0, we put it here. Then we take 3 times 1 plus 2 times 0. So we get here 3. So we just take the row 2 times column 1, because remember we start with the row then column. Then if you add the element here, we'll take 4 times 2, 4 times -2 plus 7 times 4. So here is -8 plus 28. So we are going to get 20. Then our elements at this end, we will take 3 times -2 plus 2 times 4. So here we get -6 plus 8, we are going to get 2. So the only basic that you need to remember is when you want to multiply matrices, start with the rows, then you go to the columns. So you take the row times column. So this is the product of a 2 by 2 matrix. Why do we call it a 2 by 2? You can clearly see that it has the 2 rows and 2 columns. In fact, it's a 2 by 2, which sometimes we call square matrix. So we simply call it a square matrix. And we can find the product of any given square matrix. Now this is just a 2 by 2. I want to teach you one that deals with a 3 by 3 matrix. Allow me to rub this part. Now when we have a 3 by 3 square matrix, somebody can give you 3, 1, maybe 4, -1, 2, maybe 5. Then you get 4, 3, maybe 2. Now if this is the matrix that we have, that's a 3 by 3, because we have 3 columns and we have the 3 rows. So we simply call this one a 3 by 3 matrix. So when we have a 3 by 3, we multiply, or somebody comes and asks you square, right? How do we square that particular matrix? So squaring a number, just like in ordinary algebra, simply means you take a number times itself. So I will simply take that matrix which is 3, 1, 4, negative 1, 2 and 5, 4, 3 and 2. I put a bracket. Then I multiply by the same matrix 3, 1 and 4, negative 1, 2 and 5, 4, 3 and 2. Now remember, squaring a matrix is just like squaring any ordinary algebra. You take a matrix times itself. Now how do we go about this? When you want to multiply that, remember the rule does not change. We talked about the RC. RC means you start with the row, then you multiply by the given column. Now how do we start? We know very well this is column 1, we have the column 2, and we have the column 3. So here we have the row 1, the row 2, and we have the given row 3. Now if you, at that particular, you remember these numbers, we call them entries or elements of any given matrix. So at this point, we want row 1 and column 1 to check the entry here. So what I'll do, I'll take the first row times the first column. And remember, when you consider rows and columns, the first element, second and third, the first element, second and third. So 3 times 3 is 9, 1 times minus 1 is negative 1, 4 times 4 is 16, then we add them. So here we get 9 minus 1 is 8, plus 16 we get 24. Then below it here, you take, because now we are dealing with row 2. So we take row 2 but still under the first column. So negative 1 times 3. So this is negative 3 minus 2 is minus 5. Minus 5 plus 20 we get 15. Then if we are in row 3, we deal with this row 3. So 4 times 3 is 12. 12 minus 3 is 9. 9 plus 8 we get 17. Then we are now moving here. So we are going to pick row 1 and column 2. So I'm going to use the column 2 here. Remember, this is column 1, column 2 and column 3. This is going to be row 1, row 2 and row 3. So to get the elements here, I'll take 3 times 1 is 3 plus 1 times 2 is 2. So this 3 plus 2 is 5 plus 12 we get 17. Then we move to row 2. So I have to consider this row 2. But remember, it's row 2, column 2. So I'll deal with this row and this column. So negative 1 plus 4 is 3. 3 plus 15 we get 18. Then we now deal with the row 3, column 2. So I deal with this row 3 and column 2. So 4 times 1 is 4 plus 2. So this is 4 times 1 is 4, 3 times 2 is 6. So 4 plus 6 is 10, 2 times 3 is 6, 10 plus 6 we get 16. Then we move to column 3. So I get my row 3, row 2 and row 1. So we'll start with the top here. So we take the row 1, remember this is row 1 and column 3. So the row 1 and column 3. So 3 times 4 is 12. 12 plus 5 is 17. 17 plus 8 we get 25. Then now we want to get at this point, which is row 2 but column 3. So I'll come here to get this. I'll take my row 2 but column 3. So negative 1 times 4 is negative 4. Negative 4 plus 10 is 6. 6 plus 10 is 16. Then here is row 3, column 3. So I'll deal with the row 3 and column 3. So 4 times 4 is 16. 16 plus 15 is 31. 31 plus 4 we get 35. So that's how we get the product of a 3 by 3 matrix. We start with the rows, then we multiply by the column, and you need to check the entries are what is important in this particular case. So that is, now we know how to multiply a 2 by 2. We know how to multiply a 3 by 3. But remember one thing, somebody can give you a matrix, for example, 4, 7, 3, 2, 1, 8, like that. Then you multiply a number 4, 13, and negative 1. Now this matrix, sometimes you find it cannot be multiplied, sometimes it can't be. Why? Since we go by the RC, the rows times column, so this is going to be our row 1, our row 2. So this is going to our column 1, column 2, and column 3. Now, it is very much compatible because 4 times 4, 7 times 13, 3 times that. That is workable because the number of rows should be equal to the number of columns for them to be multiplied. So we take 4 times 4 is 16, 7 times 13 is 91, so 16 plus 91. So if we take 16 plus 91, we get 107. So this is 16 plus 91 is 107. Then 3 times negative 1, we get negative 3. So we get here to be 104. Then when we come here, 2 times 4 plus 1 times 13 plus 8 times negative 1. So here is 8. 8 plus 13, we get 21. 21 minus 8 is 20 minus 7, which is 13. Then the same here, you see now we are already done. So we've multiplied this, this and that to get that. Then this, this and that. So what do you note? Now we clearly see that the matrix we are going to find here, remember we start with the rows then column. So this matrix is, how many rows do we have? 1, 2. So these are 2 times columns, 1, 2, 3. 2 times 3. So we are multiplying by which order? How many rows? 1, 2, 3. So 3 rows times 1 column. These are 3 by 1. These are 2 by 3. Then whatever we are getting here is how many rows? 2 times 1 column. So what do you note? The number of rows must be equal to the number of columns when we get the product of that matrix. So at least I've shown you how to multiply a 3 by 3 and to multiply a 2 by 2. The other question that was asked by some students is how do we find the determinant of any given matrix? So you will allow me to wrap this. Then I teach you guys how do we find the determinant of a matrix. Now I'll teach you guys how to find the determinant of any given matrix. Let me clean it well. Now, what we are going to do, we want to look at what is this determinant. We are now going to find the determinant of any given matrix. Now, let me start by a 2 by 2. If somebody give you a number like 1, 2, maybe 13 and negative 4. These are 2 by 2 matrix because it has the number of rows. This is row 1. These are columns, sorry. So this is column 1 and we have the column 2. So this is row 1 and we have row 2. Now for you to find the determinant of any given matrix, it is always something very basic, just like having the A, B, C and D. By the moment we have this and we want to find the determinant of any given matrix, what you're supposed to do is always consider the leading diagonal. Then we have the minor diagonal. So the leading diagonal becomes the AD minus BC. That is how we find the determinant of any given matrix. So that's one of the basics I want you to note. That how do we find the determinant? We take the leading diagonal minus the minor diagonal. So the moment you know this as a concept, anytime you want to find the determinant, and remember, determinant can sometimes be written with two absolute values. So what am I supposed to do here to find the determinant? You can come and say the determinant of that particular matrix will be 1, I'll use brackets to mean multiplication, 1 times minus 4 minus 2 times 13, 2 times 13. So here we get negative 4 minus 26. But remember, negative becomes a plus, so we are going to get negative 30. So anytime you want to find the determinant of any matrix, it is simply the leading diagonals product minus the minor diagonal. An example, you may be given even decimal. Somebody can give you maybe negative 0.4, 5, maybe 1.5, and maybe 6. If this is the matrix that you have called it maybe matrix A, then in exam they will basically come and ask you find the determinant of A, which sometimes is abbreviated with the two absolute values. So that one simply means the determinant. So what are we supposed to do? You take the leading diagonals product, which is negative 0.4. You have to multiply by 6. So multiply by 6. So what are we supposed to get? 0.4 times 6 is 2.4. So we get it negative 2.4. So that is the product that we are getting from this particular end. So this is the determinant of a 2 by 2 matrix. So from today you know how to get the determinant. Simply the leading diagonals product minus the minor diagonal. And those are the entries in that. But if you find a matrix that the determinant of that matrix is equal to 0, we normally call it singular matrix. We call it singular matrix. So throughout your calculation and the studying of maths, when you find that a matrix does not have any determinant, which means it will not also have an inverse will not be found, it will be 0. So that is called singular matrix. I'll wrap this part, then teach you how do we find the determinant of a 3 by 3 matrix. So that is the determinant of a 2 by 2. Now I want us to move to 3 by 3 matrix. How do we find the determinant? I'll take you through now a 3 by 3. Now I'll give you an example of a 3 by 3. Then we see how do we find the determinant of a 3 by 3 matrix. If I give you 2, 4, remember in matrices we don't put those commas. Let me check the one writes well. Maybe 2. We get 4, negative 1, 6, maybe negative 3, 0, 5. If you call this matrix, call it A, then somebody asking you to find the determinant of that matrix, how do we go about it? Determinant of a 3 by 3 matrix is a little much different. In which format? They can come and ask to find that, which simply means it is the determinant of a 3 by 3 matrix. Now this is what we are supposed to do. For us to find the determinant of a 3 by 3 matrix, we find something called cofactor matrix. We find the cofactor matrix. So the formula is always you write plus, minus, then plus. How do you go about this? You consider the first entry. We have 2. So we are going to put plus 2. Then you get the cofactor matrix. So when you go at 2, you delete the entire column and the entire row, which means if you delete this column and you delete this row, because I've identified 2, so you delete that column and that row, so whatever remains is this matrix, negative 1, 6, 0, 5, negative 1, 6, 0 and 5. Then the next part under the formula was supposed to be plus, then minus the element here 4. When you identify this 4, you also delete that entire row and you delete this column. So whatever remains will be 4, 6, negative 3, 5. So the element that remains is what forms our next cofactor matrix, which is 4, 6, negative 3, 5. 4, 6, negative 3, 5. Then lastly, under the formula plus, minus, then plus, the last one should be a plus. We identify 2. Then we also delete that column and delete that row. So whatever remains here is 4, negative 1, negative 3, 0. So we have 4, negative 1, negative 3, 0. Now when we get this matrix, now we formed a 2 by 2 that we can easily find the determinant. So we are going to write 2 into the determinant of this matrix will be negative 1 times 5 minus 6 times 0. So here is minus 5. Then here we have minus 4 times 5 is 20. 6 times negative 3 is negative 18. So 20 minus negative 18 is 20 plus 18, which is 38. Then lastly is plus 2 into 4 times 0 is 0. Negative 3 times negative 1 is positive 3. So 0 minus positive 3 becoming minus 3. So here we are going to have negative 10 minus 4 times 38 is the same as 76 by 2, which gives you, let's multiply 38 by 4. We get 32, we carry 3, here is 12. So we get 152. This is 32, we carry 3, 152. So it is minus 152 minus 6. So when we minus everything is like negative 162, negative 168. So the answer becoming negative 168. So this is the determinant of a 3 by 3. But remember one thing, the formula should remain plus, minus, then plus. That's how we get the determinant of a 3 by 3. Identify the top element with a positive here, the next is negative, then positive. Then you create those cofactor matrices. Those are now the cofactor we talk about. So that's how we find the determinant of a 3 by 3. The next part here that you can be asked is to find the inverse of a matrix. How do we find the inverse of any given matrix? Let's have a matrix of the form 4, negative 1, 3, 6. And in matrices, you must always form a bracket. Now, if we have that particular matrix, which is a 2 by 2, how do we determine the given inverse? So the steps, the first step is, call this matrix be A. So the first step you must find is the determinant of the given matrix. I know they may not have asked you to find the determinant, but they just come and say, in fact, the question normally comes, they will definitely put that, find A raised to negative. So this is simply the inverse of that particular matrix. So how do we go about it? The first step is to find determinant of A, which is what I've already covered with you, 4 times 6 minus negative 1 times 3. You start with the determinant. You simply multiply the leading diagonal product minus minor. So here you get 24 minus, but remember this is negative 3. So minus minus becomes plus 3. So we get it supposed to be 27. That's the determinant. Then for you to get the A inverse is always 1 over determinant of that matrix times adjoint. times what is called the adjoint matrix. Yeah, for you to find the inverse, you take 1 over the given determinant, you multiply by the adjoint. So what is the determinant that we worked out? Our determinant was supposed to be 27. So we take 1 over 27. We simply multiply by the adjoint of that given matrix. The adjoint means they interchange. The 6 comes at the position where we have 4. Then 4 goes down. But others remain, but we change the nature of their signs. Yeah, that's one of the basics, that for you to get the inverse of any given matrix, the step number 1 is to find the determinant. This is a very important step that every student should remember, that you must always find the determinant of that matrix. Then the next step to find the inverse, simply taking 1 over that determinant times its adjoint. How do we find the adjoint of a matrix? We simply interchange the leading diagonals entries or the elements. You see 6 comes here, 4 goes down. The others remain, but we negate them. An example, if I were to give you A, B, C, and D, how do we find the adjoint of that A, B, C? So it becomes D, A, negative B, negative C. So that's how we find the adjoint of any given matrix. So this is the inverse of our 2 by 2. Now the next step now, I want you guys to take you through the inverse of a 3 by 3. So allow me rub it first so that we can go to a 3 by 3, which is now, will take a little longer step. Now, I want to teach you how to find the inverse of a 3 by 3. The 3 times 3 inverse. Now, we have to pick the matrix first. Let our matrix be 3, negative 1, 4. Maybe 7, 5, 2. Let us have maybe 2, maybe 7, 8. If this is the matrix, call that matrix to be A. Then they will give you 7 marks and ask, find A inverse. So when you find this in exam, you have to show all the steps. Number 1, step number 1 that is very important, you have to find the determinant of that matrix. And how do we find the determinant? We go to plus, minus, plus. So we start with the plus 3. Then we delete the entire row and the entire column. So if I delete this and I delete that, I'll remain with these entries, which is 5, 2, 7, 8. Then the next is plus, minus. Remember the minus of the minus now becoming plus 1. Then if I choose here, so now we are here. So we delete the entire column and the entire row. So assume you've deleted this and you've deleted that. What will remain will be 7, 2, 2, 8. So 7, 2, 2, 8. Then lastly is a plus. So I identify that, which is plus 4. Then you delete the entire column and the entire row. Pretend you've deleted this and that. The entries remaining will be 7, 5, 2, 7. 7, 5, 2, 7. Then here we are going to have 3. Remember, these are now 2 by 2 matrices. 8 by 5 is 40. 40 minus 14, we get 24. Plus 1. 8 times 7 is 56. 56 minus 4 is 52. plus 4. 7 by 7, 49 minus 10 is 39. Then 3 times 24, we get 72 plus 52 plus 39 times 4 is the same as 78 by 2, which gives 156. Because this is 36, I carry 3, 12, 15. Then we add this. So 72 plus 52, we get 124. 124 plus 156 is 280. So we are supposed to get 280 here. If we do the addition, we get here 4, we get here 12, then 156. Yes, we get 280 to be the determinant of this matrix. At this stage, the examiner may give you 2 marks, 1 mark here and 1 here. Remember, getting the inverse can go all the way to 8 marks. So by getting the determinant, then we know very well for us to get the inverse of any matrix is 1 over that determinant times the adjoint. How do we find the adjoint over 3 by 3 matrix? Number 1, we have to create other entries, which I'll show you how to create. It will be plus, minus, plus, minus, plus, then minus, plus, minus, then plus. Now, in other words, I come here, the first entry, column 1 and row 1. So if it is 3, you highlight that. So you delete the entire row and the entire column. So whatever remains here, which is 5, 2, 7, 8. So allow me rub it so that I make them a little bit clear, because that is the most important part. So remember, the method is plus, minus, plus, minus, plus, and minus, plus, minus, then plus. So I'll start with the plus here to create that entry. So if I identify 3, I delete the entire row and the entire column. So this is what remains. 5, 2, 7, 8. 5, 2, 7, 8. Then here is a minus at the middle here, minus here. But remember, it was negative. It was a negative here. So when you come here, you delete the entire row, you delete the entire row and the entire column. So we'll have 7, 2, 2, 8. 7, 2, 2, 8. 7, 2, 2, 8. Then the last part is plus at this point. So if I identify here, I delete that column and I delete that row. So I have 7, 5, 2, 7. 7, 5, 2, 7. Then I come here, which is a minus at this end. If I identify 7, we delete the entire row and the entire column. So we will have negative 1, 4, 7, 8. Negative 1, 4, 7, 8. Then I go to the middle, which is a plus. The middle here, you delete the entire row and the entire column. So after deleting this and that, you will remain with the ends. 3, 4, 2, 8. 3, 4, 2, 8. Then the last part is a minus here. After identifying 2, you delete the entire column, delete this and delete that. So we'll remain by 3, negative 1, 2, 7. 3, negative 1, 2, 7. Then I come down here, which is a plus. At 2, I will also delete that row and that column. We'll remain with negative 1, 4, 5, 2. Negative 1, 4, 5, 2. Then I come here, which is a minus, which at 7, delete that row where 7 is and that column. So you will remain by 3, 4, 7, 2. 3, 4, 7, 2. Then lastly, we have the positive at 8. Delete the entire row, the entire column and the entire row. We will remain by 3, negative 1, 7, 5. 3, negative 1, 7, 5. Then we get those determinants to create what is called adjoint before we transpose it. So what do we get? 8 times 5 is 40. 40 minus 14 is 26. And remember, it was a positive. 56 minus 4 is 52. Remember, is a negative. 49 minus 10 is 39. Remember, is a positive. Negative 8 minus 28 is negative 36, but it was a negative. So negative of the negative 36 becomes positive 36. 8 times 3 is 24. 2 by 4 is 8. 24 minus 8 is the same as 20 minus 4, which is 16. Yeah, so we get 16. Remember, it was a positive. 21 minus minus here, because it's 21 minus minus 2, which is 21 plus 2, which is 23. Remember, it's a negative. Then negative 2 minus 20, minus 2 minus 20 is minus 22, because it was a positive. 6 minus 28, 6 minus 28 is minus 22. But minus 22 having a negative, now it becomes a plus 22. 15 minus minus 7, because these are negative. So 15 minus minus 7 is 15 plus 7, which is 22. Now by having this matrix, before you find the inverse, now we need to know that we have to get what is called matrix transpose. We transpose this matrix. We turn all the rows to columns. So row 1 becoming column 1, row 2 becoming column 2, row 3 becoming column 3. That's what we call, we transpose this matrix. So take the row 1, which was 26, negative 52, 39. 26, negative 52, 39. Then our row 2 becoming our column 2. We get 36, 16, negative 23. Then our row 3 becoming our column 3. Negative 22, 22, 22. Negative 22, 22, and 22. Now this is the matrix transpose. So our matrix transpose of the cofactor matrix becomes the adjoint of a 3 by 3. So for you to get your inverse, you take 1 over the determinant that we had already worked out, which was 280. Then we multiply by that given transposed matrix, 22, 39, negative 23, 22. Then you open the bracket, take 1 over 280, multiply by each and every given entry. So that becomes the inverse of any given 3 by 3. But remember one thing, if you find a matrix is the same as its transpose, we call it symmetric matrix. It's called a symmetric. So anytime you transpose, turning all the rows into the columns, then finding it's the same as that matrix, so we normally call it a symmetric matrix. And this is basically what is taught so much up to the A levels, where students should know that if you want to get the inverse of a 3 by 3, you must start with the determinant by getting those small cofactor matrices. After getting the determinant, the inverse will always be 1 over determinant times adjoint. How do we find the adjoint of a 3 by 3? We get those cofactor matrices. After getting the matrix of those entries, then we transpose. What is the meaning to transpose? We change rows to columns. Row 1 becoming column 1, row 2 becoming column 2, row 3 becoming column 3. And remember the procedure of the RC. We usually start with the rows, then we go to the columns. So that is far whenever you have been given a 3 by 3. So now we know how to multiply a 3 by 3 matrix. We know how to find the determinant of a 3 by 3. We also know how to find the inverse of a 3 by 3. The same as we find for the 2 by 2. But remember one thing. You can only find the inverse of a square matrix. For you to find the inverse of any matrix, it must always be a square matrix. Now I want to give some example of an application questions. After that, you can pause the video, then you go through it by yourself. But let me rub so that I see what type of a questions should they test for the application. Now, I'll be teaching you guys, we'll figure out some of the problems that they normally ask you in any given exams. Those people doing the IB, International Baccalaureate, those doing the Cambridge, American system, all that. You know, the content doesn't change. Now, an example, somebody can come and give you, use matrices to solve. They can ask you to use matrices to solve any system of equation. If they can give you 2x minus y is 13, maybe 3x plus 4y is 8, then they ask you to solve that system by the use of what? By the use of matrices. Now the first step for you to solve this, you know, in maths we must always follow some steps. You must find what is called a coefficient matrix. So we are going to have the 2, we are going to have 3, we are going to have -1, we are going to have 4. Then you close that bracket. Remember, your first variable was x, then y. So we put x, then y, which must also be bracketed, equals 13, 8. That is step 1. We call it a coefficient matrix. Why? Because if we multiply, we get back to our system here. Remember what I told you. You start with the rows, then you go to column. So if I take row 1 times column 1, 2 times x plus -1 plus y, which is 2x minus y, equals to the top here, which is the same. Then if you take the row 2 times column 1, which is 3x times 3x plus 4y equals to 8. So this will earn you 1 mark sometimes if you're still, those people are in high school. Now, after determining the coefficient matrix, we need to pick that matrix. That matrix, call it M, which was supposed to be 2, -1, 3, and 4. Then find the determinant of that matrix. How do we find the determinant? I already taught you that the determinant of a matrix is the leading diagonals product minus. So 2 times 4 is 8. 8 minus -3, which is 8 plus 3, which is 11. So the determinant is 11. Then the next step is to find the inverse of that matrix that you have created, which I had already said is always 1 over determinant times the adjoint of that matrix. Now we take 1 over 11, then we multiply by the adjoint. How do we get the adjoint over 2 by 2? They shift the positions, the leading diagonal. 4 comes here, 2 goes down. So we have 4 and 2. The other elements, entries in the minor, they remain, but they change the nature of their sign. If it was negative, it becomes a positive. If it is positive, it becomes a negative. Then the moment you found the inverse, you multiply both sides by inverse. But remember, whenever you take a matrix times its inverse, you get the identity. What do I mean by identity? Let us take this matrix. You should get something like 1, 0, 0, 1. So if you take that inverse, which is 1 over 11, 4, 1, -3, 2, when you multiply by the matrix itself, which was 2, -1, 3, 4. 2, -1, 3, 4. Let's try and see what is coming out. So we have 1 over 11 into. So 4 times 2 plus 1 times 3. So this is 8 plus 3 is 11. Then -3 times 2 plus 2 times 3. So -3, -6 plus 6 is 0. Then 4 times -1 plus 1 times 4. So -4 plus 4 is 0. -3 times -1 is 3 plus 8 is 11. So 1 over 11 times 11 is 1. 1 over 11 times 0 is 0. 1 over 11 times 0 is 0. 1 over 11 times 11 is 1. So you see we get the identity matrix. So it implies when you take that inverse, then you multiply both sides. So what you will get on your left hand side will simply be the identity. So by taking this matrix I multiply both sides by the given inverse. So this side, after multiplying a matrix by its own inverse, we get 1, 0, 0, 1. So whatever we are going to have here is x and y. So we get x, y. It's supposed to be the same matrix we multiply by the inverse. So we are going to take that particular inverse, which was supposed to be 1 over 11, 4, 1, negative 3, 2. Then we multiply by 13, 8. Yeah, in other words, it's like getting reciprocal of a number. In many cases, you guys learned, if somebody gave you 3x is 6, what were you supposed to do? You multiply by reciprocal both sides. So x is supposed to be 2. The same as in matrices. Get the inverse, then multiply both sides by the given inverse. So you come here and say 1, 0, 0, 1 as a product with xy becomes 1 over 11, 4 times 13 plus 1 times 8. So here 52 plus 8 is supposed to be 60. Negative 3 times 13 plus 2 times 8, this is negative 39 plus 16. Negative 39 plus 16 is the same as negative 29 plus 6, which is negative 23. Then you come and say 1 times x plus 0 times y. So this is x equals 1 over 11 times 60, which is 60 over 11. 0 times x plus 1 times y is y, should be 1 over 11 times negative 23, which is negative 23 over 11. So that now is the solution to this particular system. So that is one of the ways we normally use the matrices to solve any simultaneous equation. By simply starting with the determinant, after finding the determinant, find the inverse of that given matrix. After finding the inverse of that given matrix, then multiply both sides by the particular given inverse. So you may get the solution to that. And it doesn't stop there, because you may find in an exam they provide you with a 3 by 3 system. Allow me to rub this, then I show you that step. How do we go about a system of that form? We want to pick one so that we will be done by most of the type of questions they set. Now, let's start with something that you know. I want us to work from something known to unknown. Let me come and tell you that x, let me say if somebody give you x is equal to 2, y is 1, and maybe t is 3. Now, we know very well that if you take x plus y plus t is supposed to be 1 plus 2 plus 3, so you get it 6. Now, what if I come and say maybe 2x minus y plus 4t? What is it supposed to be? 2x. Already we know the values. I start with known to unknown. Now, if you know x is 2, so 2 times 2 is 4, minus 1 is 3, 3 plus 40, which means 3 plus 12, you get 15. Then somebody comes here and maybe put negative x plus maybe 4y minus 2t. What is it supposed to be? Minus x is minus 2 plus 4y. So 4 times 1 is 4. So minus 2 plus 4 is 2. So 2 plus negative 2 times t. What did I say? Minus x, which is minus 2 plus 4y plus 4 minus 2 times t, and t is 3. So this is minus 2 plus 4 minus 6. So it's like 4 minus 8, which is minus 4. Yeah, the answer should be minus 4. Now, yes, we know this. What if you did not know this? Somebody just came with the system and said x plus y plus t is 6. This is now the system of the equation that has been provided. How do we go about it? Number one, now we know the values. Assume we did not know. If you did not know, this can take about 10 marks to those people in A levels. First of all, you come with what is called coefficient matrix. The coefficient of x is just 1x, then 1y, 1t. Then we go to 2, negative 1, because it is just minus 1y, plus, which is 4, then negative 1, 4, minus 2. Now, if this is the matrix you have, then we multiply by x, y, t. X, y, then t, which now should provide 6, 15, and negative 4. Now, by having this system means you must first of all find the determinant of this matrix before you find the values. How do you find the determinant? To find the determinant of a matrix, I said plus, minus, then plus. So it is plus 1. Then I delete the entire row and the entire column. So we have this, which is minus 1, 4, 4, and minus 2. Then minus here, which is minus 1. I delete the entire column and the entire row. I will remain with the 2, 4, negative 1, negative 2. 2, 4, negative 1, negative 2. Then lastly is supposed to be a positive 1. If it is here, I've already identified that. So I'll delete this column and delete that row. So I'll remain with the 2, negative 1, negative 1, 4. 2, negative 1, negative 1, 4. Then we find this determinant. So negative 2 times, so it is just 1 outside into negative 2 times negative 1 becoming 2 minus this 16. Then here is minus 1 minus 4 minus 4 times this, which is now plus 4. Remember, we are minusing. So this is minus 4 is minus of this minus. So it becomes a plus. Then lastly, it's plus 1 into 2 times 4 is 8. 8 minus the product of two negatives, just get 1. So we get here negative 14. Negative, this is 0. 0 times that is just plus 0. Then we get 7. So negative 14 plus 7, we simply get negative 7. So this is the determinant of the coefficient matrix of that system. Now the next thing, immediate thing that we do, like I had told you earlier, for us to solve that, we need to find the inverse. That matrix inverse should be 1 over the determinant of that matrix times its adjoint. Now you come and take 1 over negative 7 times the adjoint. And I've already taught you how to find the adjoint of a 3 by 3 matrix. Now we pick that matrix and we find, now we have its determinant, we get its adjoint. How do we get the adjoint? We get all the cofactor matrices, then we transpose. So you are supposed to pick it here. So I come here. Remember, it is, we start with a positive. Allow me to rub this end. So it's a plus, minus, then plus, minus, plus, then minus. Then we get to plus, minus, then plus. We alternate. Now this is the cofactor matrix we want to identify. So you come here. You delete the entire row and the entire column. So we will have this matrix, which is negative 1, 4, negative 1, 4, 4, negative 2. Then coming here, which is at 1 here, we delete the entire column and the entire row. So we'll have 2, 4, negative 1, negative 2. 2, 4, negative 1, negative 2. Then lastly at this corner, which is supposed to be 1 here, delete this column and delete this row. So we'll have 2, negative 1, negative 1, 4. 2, negative 1, negative 1, 4. Remember, if you mess even one, it will affect the entire answer. Then coming at this corner, which is here, it's a 2. Delete the entire row and the entire column. We'll have 1, 1, 4, negative 2. 1, 1, 4, negative 2. 1, 1, 4, negative 2. Because we had identified here 1, 1, 4, negative 2. Then in the middle here, which is in the middle here, delete the entire row and the entire column. So we'll have 1, 1. We'll have 1, 1. 1, 1 in the middle. Then negative 1, negative 2. Then the last part here, which is 4, delete the entire row and the entire column. So we'll have 1, 1, negative 1, 4. 1, 1, negative 1, 4. Yeah. 1, 1, 1, 1, negative 1, 4. Then at the lower corner here, which is at negative 1, delete that column and that row. So we'll have 1, 1, negative 1, 4. 1, 1, negative 1, 4. So it behaves the same as the previous. Then if you come here at 4, delete the entire row and the entire column. So we'll have 1, 1, 1, 4. 1, 1, 2, 4. 1, 1, 2, 4. Then the last part here, delete that row and that column. So we'll have 1, 1, 2, negative 1. 1, 1, 2, negative 1. Then we get that matrix. We need to find it first. So we are going to find negative 2 times negative 1, which is 2, positive now, 2 minus 16, which is supposed to be minus 14. Supposed to be minus 14, because these are positive. Then coming here, negative 4, this is negative 4, minus 4. Remember, minus 4 is minus 8, but there's a minus here, so it is a plus 8. Then coming here is 8 minus the product of the two. Negative, negative is positive, so which is 7. And remember, it is supposed to be a plus. Like this here, it affected the negative. So coming here is, at the lower part here, negative 2, we take here negative 2 minus 4, which is minus 6. And having a minus, so it is a plus 6. In the middle here is minus 2 minus 2 minus the product, which is minus 1. So minus 2 minus minus 1 is plus 1, which is negative 1. So we put here negative 1. Remember, this is a negative 2, and we are minusing the product here. So it becomes a plus, which is a minus 1, which is a positive here. So here we take 4 times 1 is, which is 4, minus 1, which is 4, plus 1, which is 5. But remember, it's a minus 5. Then coming here, we are supposed to have 4 minus negative 1 times 1 is minus 1. So it is the minus of the minus 1, which is supposed to be a 5. Then coming here, remember, it's a negative. So 4 minus 2, which is 2, becoming a negative. Then lastly here, minus 1 minus 2. These are products. So being a minus, so we get a minus 3. Now this is the matrix, cofactor matrix. But for us to find the adjoint, we need to transpose that matrix. How do we transpose? So for us to get the inverse of that matrix, we take 1 over the determinant we had already worked out, which was minus 7. Then we multiply by the transpose, make row 1 to be column 1. So we are going to put negative 14, 8, 7, 6. Let me wrap that 6, negative 1, negative 5, then 5, negative 2, negative 3. Now this is the inverse, because we've taken 1 over determinant times its transpose. Because the transpose of a cofactor matrix is the adjoint of a 3 by 3. Then the thing we'll do, We multiply. Remember, when you take a matrix times its inverse, you should get the identity. Like in this case, our identity should be something like 1, 0, 0, 0, 1, 0, 0, 0, 1. So, when you take that matrix, so what we can do, we multiply both sides. 1 over negative 7, 14, which is negative 6, 5, 8, negative 1, negative 2, 7, negative 5, negative 3. So we multiply by 6, 15, negative 4. 6, 15, negative 4. So negative 14 times 6 is 84. What is 14 times 6? We get 84. So this is negative 84. 6 times 15 is 90 plus 90. We are multiplying this, that, then 5 times minus 4 is minus 20. So it's like taking 90 minus 104, which is negative what? Negative 14. So having here it is 1 over negative 7 into, so the row 1 times column 1 providing negative 14. Then row 2 times column 1, so 8 times 6 is 48. Negative 1 times 15 is minus 15. Negative 2 times negative 4 is plus 8. So 8 plus 48 is 56. 56 minus 15 we get 1. We get, what are we supposed to do here? 8 times 6 is 48. We are multiplying this. The row 2 times column 1. Then this is 48. This is minus 15. This is plus 8. Oh, this is 48. So 48 plus this we get 56. Minus 15 we get 21. Then 7 times 6 is 42. Negative 5 times 15 is negative 75. Negative 3 times 4 we get plus 12. So 12 here we get 54. 75 minus 54 we get 1. We get 41. Negative 41. So if you are to find the first part, which is x, when you want to get the first x, you take negative 1 over 7 times negative 14. The negative goes, so we get 2. X is 2. Was our x 2? Yeah, the x was 2. Now we know our first value x is supposed to be 2. The second value, which is y, is supposed to be negative 1 over 7 times 21. So that was a negative. So 7 goes here 1, 7 goes here 3. So what's supposed to be our y? No, our t. Our t is the one is supposed to be 3. But in a nutshell, you must just know how to get the determinant, then get the inverse of that given matrix, then multiply both sides by the inverse. But remember, even if you just miss, instead of putting this negative 2 to be a positive, it affects the entire calculation. So you may lose all the 10 marks, maybe getting some few steps that you work here. So what am I talking about? I want to end this lesson. But remember, whenever you have been given a system of equation, like here we have a 3 by 3 system, please form the coefficient matrix. After forming the coefficient matrix, get the determinant of that matrix. And if it is a 3 by 3, take 1 over determinant times adjoint. How do you find the adjoint of a 3 by 3? Identify the cofactor matrices, work out that matrix, then transpose. What is the meaning to transpose? You change the rows into columns, then you multiply by the 1 over determinant. But always believe when you multiply the matrix times its own inverse, you get the identity. And you can see how we have worked out the solution for the t to be 3 and x to be 2. Very easily. But I started with what we had already known from the beginning. But in an exam, nobody will give you this. You will be working from unknown. You will just be given a system of equation. So guys, you can watch most of our videos. You can subscribe. My channel is, I'll write it here for you guys, so you can subscribe, you can follow through. So basically what we do in Disneyland, we do lots of mentorship, guiding students on studying techniques. which we do online platform. We also do it on face-to-face. But if you find a student is far, an example, the one we have in Germany, the one we have in Canada, in United States, across, elsewhere, even here in Kenya, we do both the online and face-to-face. So you can subscribe to my channel. The channel is Disneyland International. You can subscribe, and you can also reach me. Some of the parents that have been looking for some people for the mentorship, you can get in touch so that we find the best way of helping your child. But this program works. We mentor students, we guide them, we come up with the materials for their studying, and it has really worked. We get very positive reports across, because the schools of today, the children do not know the method, they don't know the models on how to use. They've just been taught to use the formula and compute the workings without necessarily understanding the concept. So we have a program for mentorship. We have Cycle 1, Cycle 2, all the way to Cycle 4 in a year. So you can register in any of our cycles. You can go through our website, which is www.teacherboazfoundation.com, and keep in touch with us. Otherwise, guys, subscribe to my channel. You can like and also share. Thank you, guys.